Thank you, Clayton, for the introductions. Good afternoon, everyone. The title for our presentation for today is The Understanding of PRRS Infection Dynamics in Growing Pigs in Control and Elimination Programs. So today, Dr. Yeske and I will give this presentation in a interactive format. And Paul will start with the background and a few very interesting concepts around the topic, and then I will come up with some data analysis, and then we're going to open the floor for discussion.
All right. Well, I just put this, I put a few slides in here just going back and thinking about this concept. Back in 2008, Dr. Murtaugh and myself did the Pigeon lecture, and we had some theories about what's going on with the spread of PRRS virus. And when we looked at one of the theories we had was that, oops, my animation isn't working. Okay. That the PRRS virus starts in the positive finishing pigs, spreads to negative finishing pigs we bring in the area, then goes to the sow farm. Sow farm makes more positive pigs, and we just keep the cycle going until the cycle gets to be a blur and we can't tell where the infection process begins or ends. And part of the frustration we've all had in the area of regional control projects and being able to understand how we can control PRRS. We had the opportunity with one of the companies that we work with to be able to define a very small region. And fortunately for us in this region, it was located in a very pig-dense area, about 3 miles. For those of you that know Minnesota geography, we're about 3 miles from Martin County in the second most pig-dense county. So again, very pig-dense area, but happened to be an area where they controlled all the pigs in that area. When we look at what the farms looked like in that area, we had 3 sow farms, about 11,000 sows, 3 nurseries, about 11,000 nursery pigs, 1 finisher with 5,000, and then we had 4 wean to finish that would be double loaded, so at times they'd have upwards to 25,000 or 12,000 pigs on site. So somewhere in the neighborhood of 52,000 pigs within that region. And again, no other outside source pigs coming into that region, so there was no other concerns that we had to worry about other pigs coming there. Again, all the same ownership. We talked about the no outside pigs, and the pigs were sourced from known PRRS negative status farms. So we knew we were bringing negative pigs to the sites. And this is just a map of that region, so you can see the sow farms here, kind of right in the middle, and then we have the nurseries, wean to finishes around the area. And just to give you a little history of the area, we did start tracking this area early on, and the herds were breaking as we first started working with them about every 6 months. And essentially, the goal was to try and commingle pigs from these 3 sow farms, and it would just seem to spread from farm to farm, and we were never really able to commingle the pigs because the status of the farms were always changing. We decided, this has been quite a few years ago now, to try and do a depop repop in the area and see if we couldn't clean up the area, because we controlled the area. We thought there was an opportunity here. So we did a depop repop. We got the last sow farm ready to repop, and it turned positive. So decided that strategy didn't work. And then filtration was becoming more popular and more reasonable, and so we decided to go ahead the next step to filter the sow farms and then try and repopulate the finishing area once we got the sow farms and source them with known negative pigs. And so that was the next step we did. Unfortunately, we would see the finishers continue to go positive, and then it was just a matter of time before a sow farm would go positive. Even with the filtration, it took longer now because we were filtered, but we still had them going positive. And we would still try and refill the area with negative pigs, empty everything out, and continue to test these farms and be frustrated because we continue to have virus moving in this area. And the sow farms, when we're talking about how are they monitored, we did either sows in gestation or we did piglets on the sow at the time of weaning on positive farms, sows in gestation on the negative farms, piglets on the positive farms. And we did oral fluids in the nursery and finishing sites around. Again, once we found a positive. Oftentimes we had to go do blood samples to get a good enough CT to do sequencing. I pulled a couple examples here just to show you, and I'm sorry that we lose the legend over here, but these top three are the sow farms that were located right in the middle. And these would be the nurseries and the wean to finishes. And so if there's a white area, we didn't test it. If there's a green area, they tested negative. If there's a red area, they tested positive. So you can see here, and the sequence is all the numbers are all the same because they all sequence the same. So you can see here it showed up in the finishers first, and then the sow farm broke down. Here's another example a little bit later. Here it showed up a couple months ahead of time. We started sequencing it out of the finishing sites. Sow farms are all negative at this time, but then a sow farm breaks down again a couple months later. And sorry for the size of this, but it's a long time frame, and just using Excel here to show you. So you can see here, finishers break, sow farm breaks. Had some finishers break, sow farms didn't break. Finishers break, sow farm breaks. Finishers break, sow farm breaks. We had some finishers break, no break. And then we had the finishers again and the sow farm break. And we said, perhaps there's a trend. And so we wanted to do some more in-depth study on what's going on with this PRRS infection pressure in this area. Can we model that? Is there a way that being able to do this monitoring can help us understand better and predict better when problems are going to occur? And that's where we worked with the University of Minnesota here to help identify some of the risk factors.
So with that target in mind, we thought that was a great opportunity for us to analyze in a deeper way all the surveillance data that they were doing. So we ran a retrospective analysis of PRRS virus incidents in negative filter sow farms surrounded by growing pig sites. The objective of this analysis was to assess the PRRS incidence in 5 filter sow farms and its potential association with PRRS virus circulation in growing pig sites through this retrospective analysis. And why 5? Well, if you look the area map here, Paul was talking, let me see here, about the sub-region, this one, right, in the beginning. But we decided to go beyond this region and consider the whole production system just to increase the sample size of the analysis. It's basically the same characteristics that Paul mentioned, but we are including more sites. So we're including 5 filter sow farms and also 18 growing pig sites. So if you look this area, we're talking about a radius of 12 miles on the area. So we took the surveillance data and we took a retrospective data from 208 weeks of 4 years. And we ran a very simple descriptive epidemiology analysis. We used tools like cumulative incidence, incidence rate, infection rate, and regression analysis. Here you can see the timeline of the different events on outbreaks on the five sow farms. Here we have the 5 sow farms, and we have the timeline of 4 years. This timeline goes from fall 2013 through winter 2017, a few weeks from this year as well. As you can see in this timeline, we got 1 outbreak in 2 farms, farm 1 and 5, and also we have 2 outbreaks events on farm 2 and 3. And we got 1 farm without any outbreak during that observation period. So we took this timeline and we generated some metrics. So we got the cumulative incidence based on this observation period. It was 80%. So in other words, the probability that the farm will have at least 1 outbreak in 4 years is 80%. And also taking the 6 outbreaks and considering the sow farm years at risk contribution from the timeline, we generated an incidence rate of 1 outbreak per 3.3 sow farms years at risk. That means that it takes a period of around 3 years for 1 outbreak on those filter farms If you were in the morning, in the session this morning, Carles Villalta shows very similar incidence rate in filter farms in high dense areas. So I was really glad on see the same incidence rate on those. Here you can see also the way that we analyze the data. So we convert the surveillance data in binary data, yes, no, based on different outbreaks events. And here you can see or visualize the 5 sow farms during the whole period. These are the 208 weeks, different seasons, and you can see the outbreaks events. So here you can see the infection dynamics on these 5 sow farms, filter sow farms. Different colors means different PRRS virus strains. As you can see, we got 4 different strains during that period. And also we ran some very simple metrics around those sow farms. We generated the time to first outbreak since we started the observation period. As you can see, the median here was 97.5 weeks with the minimum and maximum there. Also, we generated the time to negative, defined as just the first week that we got the negative result, with a median of 31.5 weeks with that range. And also on those farms, which were 2 farms that they got a second infection, we got the time to second PRRS virus infection, which the median was 120. Just some descriptive metrics in order to generate that information. Also here, you can see the same format of the analysis, but considering the whole region. So here we have the 5 sow farms, and then we have the 18 growing pig sites. So in this way, each column represents the whole period, right? 208 weeks, and each row, it's a week from that system. As you can see here, we have also the different events, outbreak events in the growing pigs. And again, same color means same PRRS virus strains based on OR5 sequence and a cutoff of 2%. As you can see, some general observations here. If you look, there were 2, There were 2 growing sites that didn't break at all. And also, as I mentioned before, there were 4 different PRRS strains in sow farms. But what is very interesting here is that 67% of the outbreaks in sow farms show temporal detection in growing pigs. That means that we detect the same virus in growing pigs a few weeks before detecting the outbreak in sow farms. Also, another observation is that 83% of the growing pigs were positive, with the exception of only 3. And 93% of those sites that went positive, they had multiple PRRS outbreaks, more than 1. And also, at least, based on the sequencing, they detected 11 different PRRS strains in the growing pigs during the 4 years. Also, we conducted an analysis on the infection rate. And on the infection rate here, you can have, we have listed all the 18 growing pigs. And basically, we count the number of outbreak events per growing pigs groups placed in that specific site. That means, in this example, on growing pig site number 1, they got 1 outbreak out of 23 groups that they were placed in that site during the 4 years, and that represents 4.3% of infection rate. And the second one, 6 out of 18, and so on. As you can see here, at the total, we got 61 outbreaks out of the 255 groups placed. That represent 24% an infection rate, with a huge variability here, going from 0 to 75%. Then we learned that some of these sites, they were built during these 4 years, so that's why we got a few weeks on that. But here we're talking about nurseries, finishers, and winter finish sites as well. when we put together the prevalence in growing pigs and sow farms, we generated this chart. So here we have the weekly prevalence in sow farms, and in the other x-axis you have, y-axis you have the weekly prevalence in sow farms. And then here we have the timeline of the 4 years. And what was very interesting for us is when we follow the weekly prevalence on growing pigs, also you can see an increase of prevalence in sow farms. And if you look, the red crosses are the different outbreaks that we detected during this period. So there were 6 outbreaks. So as you see an increase of prevalence on different periods on the growing pigs, you also see an increase of prevalence and even some detection of outbreaks during from the sow farms. So we got this observation. So the next question here is this relationship is really significant, or it is just an observation? So we went deeper on this analysis, and we found a significant association between the PRRS prevalence in growing pigs and the PRRS detection in sow farms. So we found a moderate correlation, right, but significant. But also when we run regression analysis with the univariable linear model, that means just taking this variable in consideration, we came out with a significant association, and the outcome out of this was that for every 10% increase in the weekly prevalence in growing pigs, PRRS prevalence in sow farms will increase or increases by 5% with these confidence intervals. Of course, I mean, there's a lot of other factors that can be explained by this association. So we try to go deeper on this analysis, and we run a multivariable linear model considering other factors like the seasonality, right? So we took fall as the reference, and we run this with spring, summer, and winter, and also we add the variable of the prevalence in sow farms on the previous week, just to address the independency of the data. And after the second analysis here on the multivariable linear model, we're still having a significant association on the weekly prevalence, but is weaker. So we went from 5% to 1%, but the outcome is basically the same. I mean, we have, as the prevalence in sow farm increases, in growing pigs increases, the prevalence in sow farms increases. So summary of this analysis, the probability that the sow farm had at least one outbreak in 4 years was 80% in this specific production system. We estimated an outbreak for every 3.3 years of the sow farm being at risk, which agrees with previous information from this morning. There were 6 outbreaks during the study period, all lateral PRRS introduction. 2 farms suffered 1 outbreak, 2 farms suffered 2 outbreaks. On the growing pigs, the summary of this analysis, 83% of the growing pig sites were positive, and they found at least 11 different PRRS strains during these 4 years. And 93% of the growing pigs had multiple PRRS outbreaks. The infection rate per group place was 61 outbreaks out of 255. That means, or in other words, the risk of having PRRS outbreaks in growing pigs was 24% in this particular system. And when we see this, the chart about the weekly prevalence, there was a temporality of PRRS infection in growing pigs with sow farms. That means there is an association, significant association between these 2 variables, or in other words, the risk of infections in sow farms increases as infection rate in growing pigs increases as well. So, discussion on practical application of this analysis. This is an observational analysis, but in this case, we were able to identify a direct relationship between infections of the growing pigs and the risk of outbreaks in sow farms. And also this analysis highlights the importance of growing pigs in PRRS virus regional spread, as well as the value of having an active surveillance in growing pigs and some application of that. And with that, I will also let Paul to comment some of these practical applications here.
Yeah, I think the interesting thing was that we were able to show that there is a significant relationship here when you look at the grow-finish population around sow farms, and that hypothesis a few years ago, 10 years ago, looks to be like it's a valid hypothesis. The challenge is it's somewhat, as Tim would say, no kidding data. The finishers are positive, you're likely to have more sow farms positive, but I think that the value here is, can we get a tool that tells us that maybe we should come in and take an action in that area, maybe depopulate the area earlier once we start identifying that as being positive, look at using vaccination as a tool in that area, but giving us a method to predict the outcome before we actually see the outcome.
Yeah, and also the value of the monitoring and how can we use these kind of tools to generate more metrics and learn more and understand more on the production systems. Some of the limitation of this analysis, of course, we're limited on the sample size, and also these outcomes are specific for the production systems. There were also different sampling intensities on the surveillance. And I think this analysis could be considered as a conservative, because those weeks that we didn't have any knowledge about the status, we consider those weeks as a negative. So I think this will be a conservative approach. And definitely further studies are needed to better understand the role of growing pigs and the risk factors for PRRS circulation, as Paul already mentioned. And I'm glad to be as part of my master program, working with Monsi on an ongoing project that we're doing right now, measuring the incidence of infection patterns of PRRS virus in growing pigs in medium pig density areas. We're working with win-to-finish sites to identify those incidence rates and also risk factors in a proactive project, considering more systems and more basically designed to do that. This analysis, I mean, the surveillance wasn't designed to generate this kind of analysis, but we took this data and we put that this project is designed to generate that. With that, I would like to acknowledge Wakefield Pork Production System, the Swine Disease Eradication Center, and Zoetis for giving me the opportunity to work on my master's degree here in the University of Minnesota.